Okay, so before I take a minute to go over the lesson for the day, I just wanted to go over the difference between roots, solutions, x-intercepts, and zeros of the function. Okay, so basically roots, zeros, and solutions are all the exact same thing. What they do is when you plug them in, they make your equation true. Okay, so we can always write them in root form. Remember, you can always take y equals x minus your first root times x minus your second root, and then that you can multiply that out to give you the equation of your parabola, okay? Solutions are what make the equation true. They're numbers that when you plug them in, they make the equation true. So we're going to think of roots, zeros, solutions, and x-intercepts kind of all the same thing. I just want to make one differentiation between x-intercepts and solutions. So let's take a look at this first parabola. It's the equation y equals x squared minus x minus 6. Okay, if I said find the solutions, find the x-intercepts, find the roots, find the zeros, you would have to know how to solve that. And remember, to solve that, we set y equal to 0. Okay, and in this one, we have choices. We can use the quadratic formula, we can factor it. We can factor this, so let's do it that way. So in this one, I can factor this into x minus 3 times x plus 2, okay? Then you set each factor equal to 0, so x minus 3 equals 0, and x plus 2 equals 0. And you get x equals 3 and x equals negative 2. Now, those are solutions to your equation. Why are they solutions? Because if I plug in 3 for x here and here, 3 squared is 9, 9 minus 3 is 6, 6 minus 6 is 0. It makes that equation true. If I plug in negative 2, okay, it's going to equal 0. It's going to make that equation true. So those are solutions. Now, since those are real numbers, those are also x-intercepts on my graph. So in this case, I have 2 x-intercepts. Okay, that's number 1. Now, those are also roots. Okay, so these are also roots of my equation because they are x-intercepts, and when I plug them in, they make my equation true. And they're called zeros because when I set the equation equal to 0, I figured out what numbers that I plug in. When I plug those in, okay, that's what's going to give me a 0 back out. All right, now let's take a look at the difference between this one and this one. This one right here says x squared plus 49. Now that graph is going to be over here in quadrant 1. Okay, if I said to solve it, you would do the same thing. You'd say 0 equals x squared plus 49. In this case, we're going to isolate the square, so we're going to get this piece alone. So we have negative 49 equals x squared. Take the square root of both sides, and you get plus or minus the square root of negative 49. Equals x, which is plus or minus. Let's see. So it would be, we're just going to say, we're going to leave it as the square root of negative 49 for right now. Later on in the lesson today, we'll figure out how to simplify that. But for right now, let's leave it there. Now, if you notice right here, okay, this is not an x-intercept because actually here, this has no x-intercepts. Because whenever we get an imaginary number, I can't graph that on my equation, okay? So that is not an x-intercept. However, this is a solution, it is a root, and it is a 0. And here's why. Because if I plug this back into this equation, it will make the equation true, okay? And I'll show you that later on when we get to our next stuff, but I just wanted to show you kind of the difference between the two before we get into today's lesson. All right, so let's just take a minute, and we have three examples left that we did not get over in class. All right, and I kind of want you to try these on your own as we're working on them. It says, write the equation standard form of the parabola that has a vertex of -1, -5, and passes through the point 4, negative 55. All right, so we know we have a vertex at -1, -5, and passes through the point 4, negative 55. So that's going to kind of tell me that my graph looks like this, is opening downwards. All right. Now you have to decide if you're going to start with vertex form, okay, if you're going to start with factored form, or you're going to start with standard form. Now, you're never going to start with standard form. You can always multiply to get to standard form, but we're either going to start with vertex or factor depending upon what we have. Now, if you notice here, it says we have a vertex of -1, -5. All right, so I know my equation of a parabola in vertex form is y equals a times x minus h squared plus k. All right, now let's see what we can fill in. We can fill in the h, we can fill in the k, because that's my x and y values of my vertex. I'm going to leave that a blank because I don't know what it is yet. So I have x minus -1, which becomes +1 squared minus 5. Okay, so we need to solve for a. Well, how can we do that? Let's notice right here that we have this point 4, -55. This 4 is my x, and this -55 is my y. So I can fill in everything into my equation. I can fill y, x, h, and k, and leave that a there to solve for it, just like we did in class the other day. So in place of y, I'm going to put -55. A, I don't know what it is yet. X, I know is 4, because that's a point on my parabola, minus a -1, which makes that +1 squared, minus 5. Okay, so -55, do your math. 4 plus 1 is 5, squared minus 5. Okay, and then you end up with -55 equals 5 squared is 25. So it's 25 times a minus 5. Now, if I add 5 to both sides, I end up with -50 equals 25a. This doesn't turn out too bad. Divided by 25, and I get -2 is equal to a. So then what I can do is I can just plug that in. And that kind of helps me here because this is actually going to tell me that my graph is reflected over the x-axis as a negative. It's stretched vertically. It's moved to the left 1 and down 5, just as a refresher. All right, let's take a look at the next one. It says, write the equation of the parabola in standard form that has two x-intercepts at -6, 7 and passes through the point 2, -80. So let's think about what we're given. So number 1, we are given the two x-intercepts. Okay, and if I wanted to, I could write those in the ordered pair of -6, 0 and 7, 0. We're also given a point on the line, okay, and that's going to be x, y, which is 2, -80. So also remember that x-intercepts are the same thing as your roots. So we have to decide what we're going to start with. So remember, we have three choices: vertex form, factored form, or standard form. Never start with standard form. Let's use factored form here, and the reason we're using factored form is because we're given the roots, okay? So remember that factored form is going to be y equals, you have an a here, x minus your first root, okay? And then you have x minus your second root. Now, what we have here is we don't know our a value, so let's kind of leave a blank there. I have my first root, it's -6, so x minus -6. I'm going to make that a positive, x minus your second root, so x minus 7. So now what I'm going to need to do is I need to solve for a. So we're going to do that the exact same way that we did our other question, okay? So in order to do that, we're going to use this x and this y value and plug that in order to find a. All right, so I'm just going to kind of keep working down here. So y was equal to -80. I'm going to leave my a there because I don't know what it is. My x value is 2, so I'm going to put it in both of these places. 2 plus 6 times 2 minus 7. All right, take a minute and try to simplify this and solve for a. Maybe hit pause and then check and see how you did. All right, so hopefully you paused it, tried this. You're going to just add 2 plus 6 to get 8. 2 minus 7 is -5. This is all multiplied. 8 times -5 gives you -40, and then you divide, you get a equals 2. Okay, so there's your equation. Y equals 2 times x plus 6 times x minus 7. Now, if I want to write this into standard form, remember you're just going to multiply it out, okay? So let's say we have y equals 2 times x plus 6, this is factored form, times x minus 7. To get this in standard form, we're going to multiply this out here. Gonna leave my 2's just chilling for the moment. X times x is x squared minus 7x plus 6x minus 42. Okay, and then you're going to combine your like terms and you get x squared minus x minus 42, and your final step is to distribute that 2 into everything. Okay, and then that's all you do. All right, let's take a look at our last example here. All right, this last one says write the equation of the parabola in standard form that passes through these 3 points. Okay, now 2, 13, 327, and 456. First, you always want to check to see if those are x-intercepts, and you would know that if they were in the form with a number, 0, because then you could use factored form. In this case, I'm not given any x-intercepts because I don't have anything, 0. So I'm given 1 point on the graph, I'm given a second point on the graph, and I'm given a third point on the graph. You're going to start with standard form. Okay, so, and the reason you're going to start with standard form here is you're actually going to do this on your graphing calculator, okay? Now, to get your graphing calculator, the instructions are over here, but I'm going to walk through them with you. Okay, so the first thing you're going to do is hit the stat button. Okay, notice how edit is highlighted. You're going to hit enter. If you have anything in your list, hit the up arrow, hit clear, hit enter, and you do the same thing for list 2. All right, so what you're going to do in list 1, so list 1 is going to be all of your x values, and list 2 is going to be all of your y values. So just like whenever we did linear regression or linear equations, it's the same exact. So I'm going to type in my x values as 2, 3, and 4, and then I'm going to scroll over to list 2, and I'm going to do 13, 27, and 56. Okay, now the only thing I need to do now is I need to, I don't have to graph these, I could. All I need to do is hit stat, okay, go over to calculate, and instead of doing a linear regression, we're doing a quadratic regression because this is an equation of a parabola. Okay, so we know it's a parabola. We're going to hit enter. X is in list 1, Y is in list 2. You don't need to worry about frequency list. And you're going to hit calculate and you're going to hit enter. So notice here how it gives you your A, B, and C values. So A is 7.5, B is negative 23.5, and C is 30. So remember, in standard form, we have A, B, and C. So in this case, my standard form is going to be y equals 7.5 x squared, because A is always your number in front of x squared. Okay, your B value is negative 23.5, so minus 23.5x, and then your C value is always just your number, so plus 30. So this one's actually the easiest because your calculator does all the work for you.